Reading Maps by Kevin Cunningham. This is the title page. Find the truth. Everything you are about to read is true, except for one of the sentences on this page. Which one is true? True or false? Meridians are always the same distance apart, or the equator separates the northern and southern hemispheres. Find the answers in this book. Here is our table of contents. Making sense of a map, Chapter 1. A map provides information about a place with pictures instead of words. Many people think of maps as being printed on paper, but this is not always true. Museums own Native American maps painted on animal skin, Middle Eastern maps etched into clay, and Polynesian maps made of sticks and shells. Today, many maps are found online. Whatever materials are used to make them, most maps share certain features. Basic elements. One easy-to-find feature is the title. This explains what information will be in the map. A signature by the cartographer may be another element. Some maps also have the year the map was made. The legend explains the symbols used on the map. The map's border or neat line surrounds the map and all the other elements. It marks where the map begins and ends. Other elements direct a reader around the map by showing directions and how to compute distances. Some maps note the kind of projection the cartographer chose to use. The projection transfers or projects the features of the round Earth onto a flat surface, such as a piece of paper. Projections change the shapes of the Earth's features to make everything fit on a flat surface. There are countless different projections. Each distorts the Earth differently. It is helpful to the reader to know what projection was used to avoid confusion. Chapter 2. Finding Direction. No map can show all the details of the place it describes. Cartographers must make choices about what to put in and what to leave out. They make many other choices too. One of the ways map users can find direction is by using the map's orientation. The orientation links the directions drawn on the map to directions in the real world. A map's orientation is given by an element called the compass rose. Points on the rose. A compass rose's main points face north, south, east, and west. These are called the cardinal directions. They form a cross on the compass rose. 4 ordinal directions, northeast, southeast, northwest, and southwest, form an X. Most compass roses show no more than these 8 points. Other compass roses only show the 4 cardinal directions, or just a single arrow pointing north. To orient a map to the real world, a map reader first spreads the map out on a flat surface. Then she finds north on the map's compass rose. From there, she turns to face the real north and lines up the north on the compass rose with the direction she's facing. When that's done, she has found the map's orientation. It's now possible to use the map, whether for travel or for other purposes. Which way is up? Cartographers today usually create maps with north at the top. The choice may seem like the right way, but it's a tradition, not a necessity. Maps used other orientation points for centuries. In the Middle Ages, Christians in Europe often drew east at the top of their maps. This was because east pointed in the direction of Jerusalem, Christianity's holiest city. Maps made in Japan were often drawn with the emperor's palace at the top. pointing north. Greek map maker Claudius Ptolemy is considered one of the fathers of cartography. In the 2nd century CE, Ptolemy used mathematics to make maps that were unusually accurate for his time. He also oriented his maps with north pointing up. Many of Ptolemy's methods were lost until European mapmakers rediscovered his teachings in the 1400s. These mapmakers took Ptolemy's advice on orienting a map toward the north. As European ideas spread, mapmakers around the world adopted Ptolemy's tradition. Other orientations. Not everyone agrees with Ptolemy today. A kind of map called a reversed map places south at the top. This is to get people to see southern countries as being as important as Europe or North America. Other maps have to use different orientations. The South Pole sits in the center of a map of Antarctica. North is at the top, left, right, and bottom because every place on the map lies north of the pole. Changing the world. Centuries ago, people in China magnetized the tips of metal needles by touching them to magnetic rocks called lodestones. An early Chinese compass was a magnetized needle floating in water. In the 1200s, European craftsmen built a compass in a box. They painted a compass rose on a paper card placed underneath the needle. The sturdy boxed compass helped ships find their way. European sailors soon made longer journeys in search of fish, rare spices, and new lands. Chapter 3. Latitude and Longitude. Cartographers used a system of crossing lines to help map readers find locations on the Earth. Lines running east and west show latitude. Lines of latitude run parallel around the Earth. In fact, mapmakers refer to latitude lines as parallels. The parallels are always about 69 miles apart. The equator, also known as 0 degrees latitude, splits the Earth into 2 hemispheres, northern and southern. Distance by degrees. Maps divide these hemispheres into 90 degrees of latitude. Each line is numbered to show its distance north or south of the equator. A low latitude, such as 10 degrees south, runs near the equator. High latitudes cross far from the equator. The North Pole lies at 90 degrees north, usually written as 90 degrees north. The South Pole lies at 90 degrees south, or 90 degrees south. Long lines. Lines running north and south represent longitude. A line of longitude, or meridian, starts at the North Pole and ends at the South Pole. One line's distance from the next varies. The bulge of the Earth pushes meridians farthest apart at the equator. As the lines move north or south, they draw closer together and then connect at the poles. The prime meridian represents 0 degrees longitude. It splits the Earth into 2 hemispheres, western and eastern. Maps divide the western and eastern hemispheres into 180 degrees of longitude each. A meridian's number shows distance west or east. Low numbers run nearest the prime meridian, both 180 degrees east and 180 degrees west. The highest numbers of longitude share a line. That line runs through the Pacific Ocean, exactly opposite the prime meridian. A traveler going east loses a day when crossing most of this line. A traveler adds a day going west. Using latitude and longitude. Coordinates refer to which lines of latitude and longitude meet at a certain location. For example, Virginia is at 37 degrees north and 78 degrees west, but there is a lot of space between each degree of latitude and longitude. No degrees of latitude and longitude cross at Washington, D.C. In order to find the city, a map reader will need to divide degrees into smaller units. By the numbers. To provide more exact coordinates, each degree of latitude and longitude is split into 60 measurements called minutes. Using minutes, a map reader can locate Washington, D.C. at 38 degrees and 53 minutes north and 77 degrees and 2 minutes west. This can also be written as N 38 degrees, 53 minutes, and W 77 degrees, 2 minutes, with latitude always coming first. Each minute of latitude and longitude contains 60 seconds. Seconds allow map makers to show coordinates for places as small as a building. For example, the Washington Monument stands at coordinates N 38 degrees, 53 minutes, 22.27 seconds, and west 77 degrees, 2 minutes, 6.97 seconds. In other words, the latitude is 38 degrees, 53 minutes, and 22.27 seconds north of the equator. The longitude is 77 degrees, 2 minutes, and 6.97 seconds west of the prime meridian. The trouble with longitude. By the late 1600s, a ship's navigator could find latitude by comparing the position of the sun to special charts. But navigators could not measure longitude. Without it, a ship could not locate its exact position moving east and west. In 1707, England's government formed the Board of Longitude to award money to whoever solved the longitude problem. One idea was to keep a clock on a ship. The clock kept the time at a known meridian. This was compared to the ship's local time, measured by the sun and the stars. By finding the difference, a captain could work out how far his ship had traveled, but a ship's rocking made the clocks inaccurate. In 1759, carpenter and clockmaker John Harrison invented a chronometer that would remain accurate at sea. The Board of Longitude wanted to make copies of Harrison's chronometer before granting the reward. Harrison fought the board, but agreed in 1765. He received half of the money then, and most of the rest in 1773. Chapter 4. Reading the Legend. A cartographer uses a legend, also called a key, to explain how to read the map. Complicated maps tend to have longer legends because there is more to explain. Often the largest part of the legend lists the symbols or pictures used by the map maker. Symbols have several uses. One is to pinpoint natural features and man-made landmarks. Common symbols for natural features include a small cross for a tall mountain and dots for a desert. Flat but three-dimensional. A map is flat, but cartographers can use symbols to show the height of an area. On a contour map, a series of lines show the general shape of a mountain. An experienced map reader can study the distance between the lines and imagine the steepness of the mountainside. Similar symbols may show lowlands, such as marshes and even the trenches at the bottom of the ocean. Adding color. A legend also decodes the colors used by the map makers. Water, for instance, is usually blue. Mountains may be dark brown, hills light brown, and deserts yellow. It's up to the cartographer. Some maps combine symbols with colors to pass along information. Green pine trees may show the borders of a forest. The same map might use different green symbols for treeless prairies, swamps, and rainforests. Cartographers use color for very specific purposes, depending on the type of map being created. A map should study the legend to learn what each color on the map means. This avoids confusion. Take a map that uses dark brown. A map reader may have assumed brown means dry and barren, but the legend may state that brown refers only to the heights of the land. The cartographer, in other words, is saying nothing about plant life. Man-made places. Road maps in particular use symbols for man-made landmarks. For instance, an airplane icon might mark an airport. The legend helps a reader decode the road system too. Thick lines, thin lines, dotted lines, lines of many colors, all can be used to show anything from a horse trail to an 8-lane interstate highway. Shields, circles, and other shapes help the reader find specific road numbers, such as Route 90 or Interstate 10. The scale. A legend usually includes the scale for the map. The scale allows a map reader to measure a distance on the map and convert it to real-life miles or kilometers. Scales come in many forms. The commonly used bar scale shows a checkered line. On it, distances are marked every inch, every 5 centimeters, or at some other length easily measured by a ruler. Numbers show that a certain length equals a certain real-life distance. 1 inch could equal 100 miles. Another type of scale does away with pictures. Words inside the legend simply explain the scale. 1 inch equals 100 miles. Scales on many government maps use only numbers. For example, the scale 1 to 63,360 means 1 inch on the map equals 63,360 inches, or 1 mile in real life. Chapter 5. Online maps. Maps that are drawn, kept, and used only online are different from printed maps. Paper maps, once printed, do not change, but online maps are designed to change for each person. An online map user doesn't rely on a cartographer to choose what is or isn't shown. Instead, the user calls up the information she wants. Another difference is that an online map doesn't exist outside of the internet unless the user prints a copy. Levels of information. An online atlas provides a huge amount of information. For one thing, it may hold thousands of maps, far more than any print atlas. That's just the beginning. A single online map provides a gateway to many levels of information. Click a mouse or tap a touch screen and a plain map changes to show things such as railroad tracks, rainfall, or high crime areas. Google Earth. The online globe Google Earth appeared in 2005. It used pictures taken from satellites, aircraft, and other sources to map almost the entire Earth in photographs. Since then, Google Earth has expanded what it can do. Today, it provides three-dimensional views of some major cities. A user can go on a ground-level road tour of thousands of places, and one click takes users to maps on special subjects such as climate change. Changing in real time. Computer technology also allows organizations to display maps that change in real time. The Doppler radar maps found on many news sites track minute-by-minute changes in the weather. The U.S. Geological Survey website shows the location and seriousness of earthquakes around the world. With a click, a user can see quake information from the last 10 minutes, the last 100 years, or almost any other time period. From where to there. Google Maps, MapQuest, and other online mapping sites make it easy to find directions. By typing in a starting point and an end point, a user learns the shortest route to where he wants to go. He also finds out how much time the trip will take. A mouse or fingertip even allows a user to trace out alternate routes right on the map. It is also easy to move the maps around to see other places. These kinds of online maps have symbols that show restaurants, schools, and other landmarks. Clicking on a landmark in Google Maps or MapQuest opens a separate window with the landmark's address and phone number. Sometimes the window also includes a website or a photograph of the location. Other links may provide traffic information or a weather forecast. Online maps have changed how people find their way around, but reading maps has stayed the same in many ways. Making sense of a map's orientation, scale, and symbols are all starting points, whether you look at a map online or one imprinted in clay. Next time you look at a map, pay attention to its elements. You'll be an expert map reader in no time. If you'd like to pause the video, here are some true statistics and also a list of resources. Here are some important words you can take some time looking at by pausing the video, and also an index of information. The end.